Okay, so let's start. Let me know if you can see the screen. Um, you can see the screen, right? Yes, no?
Yes, sir.
Okay, so so today we will be solving some questions on convergence of sequences, mostly convergence of sequences, not even series. Right. So the definition of the convergence of sequence, right? Or you just want me to quickly give the definition and then we'll solve the problems, or we can directly solve the questions, whatever you prefer. Should I go over the things before solving questions? Okay.
Hello, sir.
Yes.
Actually, I have a doubt.
Yeah.
Today I can't attend this lecture, but is there any option as a screen recorder?
What do you mean? Can you come again? You can't attend
Oh,
today. So these lectures will be recorded and posted to YouTube.
how do I access that?
You will be given the link, I think. You will
Uh,
be
Actually,
given
I
the
have
link.
exams, so I can't attend today. That's why I entered and just wanted to ask. So
Yeah, yeah, yeah.
please don't
That's
mind.
fine. No, no, no issues. That's fine.
Okay, thank you, sir. Thank you very much.
Yeah. Okay, then let
Okay.
me quickly go over the definition of sequences. Right. Let's say a sequence is nothing but mapping from a natural number to um, maybe if you're considering the domain in real numbers, the sequences in real numbers, so you are mapping n natural number to uh, some an in real number. Okay, so this is natural number and this is real number. Right? Sequence can be interpreted like this: a function mapping from natural numbers to real numbers. Now, so let's talk directly about the convergence of sequence. So this sequence an, okay, this sequence, we say this an is converging to a, right? If it satisfies the following, right? You can give me any small number, say epsilon, right? Can't be zero, but any small number. Then I should be able to, this is an input, then I should be able to give you a number n that depends on epsilon. So I'm writing as an epsilon. Okay. So as long as my n is greater than n epsilon, right? So I should be able to guarantee I am within this epsilon. Okay. Is this clear? Yes. So the crucial thing is this epsilon, as epsilon changes, is an epsilon keeps changing, right? Um, it's clear, right? You can type in the messages if you don't wish to speak, and that is also fine. Okay, so as a consequence of this thing, you can easily verify that if an converges to A, I think this would have been proved in the lectures also. Bn converges to B. Okay, you have this An plus Bn converging to A plus B. Right, and some constant C times An will converge to C times A. See some message. Yes, this is the first problem solving session. I'm just going over some contents that will help understand the questions. Just a refresher, right? Whatever you would have learned over the lectures. And An times Bn converges to A times B, and An on Bn converges to A by B, provided Bn doesn't go to 0 for any n, and B is non-zero. Okay, so you have this thing. Now, another notion of convergence is, there's something called as Cauchy sequence. Cauchy sequence. Okay. Now, a sequence is said to be Cauchy if it satisfies this thing. Same thing, you give me an epsilon, I should be able to produce a number n epsilon if it satisfies this condition. Both n m should be greater than n epsilon. Okay. Fine. So, um, if a sequence converges, it is easy to show that it is a Cauchy sequence. Right, but if it is a Cauchy sequence, there is no guarantee that it converges. Okay, so if you have a property that every Cauchy sequence converges in a metric space, it is called as this thing, a complete metric space. Okay, so I'll give you an examples. So So is this clear, right? The distinction between the Cauchy sequence and the normal sequence convergence? Or you want me to explain it a bit more? You can type in if you don't wish to talk. I mean, ideally, I prefer if you speak, but yes, cool. So, okay, let's see quick examples. Uh, so sequence 1 over n. Okay. Okay, so this is a sequence 1 over n in R. We'll define the sequence in R. So we need to always ask whenever a sequence is defined, where it is defined, in which space. Let's say it is defined in R, where does it converge to? Can you type in message like where does it converge to? 0. Right, so this will converge to 0. That's good. Now let's say Um, I am considering sequence in Q. Okay. So and the sequence is something like this. Q is a rational, right? Set of rational numbers. And this is my underlying space. Q is my underlying space. I'm defining sequence by this thing, 1 plus 1 by n whole power n. So you see, for every n, this lies in the space of Q, right? But as n tends to infinity, where does this thing converges? Cool. That's E, right? Great. Everybody answered the same. So what is E? What is E? Is a rational or irrational? Cool, right? It's irrational, right? Q is irrational, and we are working in the space of what? Rationals. Okay. Do you see this? Can we say then this sequence converges? Definitely not in Q. Yes. So that's what I wanted to say. This will not converge in Q. But then if you see this sequence, and because any convergent sequence, it converges in R definitely to E, but any convergent sequence is a Cauchy sequence. Okay. So this thing is a Cauchy sequence in Q also, right? But then it doesn't converge in Q. So this is an example of a sequence which is Cauchy, but it doesn't converge. I mean, we can cook up very simple examples. Say 1 minus 1 over n. This is the sequence we are defining, right? Now the underlying space in which we are defining is this thing. Say close 0 to open 1. Right? And we know this sequence will converge to 1, right? And we removed 1 from the interval, and it is a Cauchy sequence. It's obvious it is a Cauchy sequence, but then it will not converge. And yeah, we can cook up any number of examples. So same thing, 0 to say minus 1 to 1, open minus 1 to 1 intersection with rationals Q. Okay, here we can say any sequence that is converging to 1 will not I mean, we are removing the ones and minus ones, right? So yeah, then these are the examples and counter examples to explain this thing. So I think this is what we need for today's problems. Okay, let me open the problems and we'll solve. Okay, so first question is, state whether the following is true or false. Consider two non-empty sets X, Y are subsets of A, B, and subsets A, B of X such that for any function f x into y, right, do we have this thing? F of A intersection B is f of A intersection f of B, right? What is the answer? It's true. Um, Sorry. I mean, just think about it. It's false. Yes, it is false. So you want me to explain why it is false? I mean, let me explain. I mean, that's fine. So it's fine. It's okay if we just give a counter example, that should suffice right here. So all we are asking is there's a function it's mapping from say x to y, and we have two subsets a b. Is it true that f of a intersection b um, is f of a intersection f of b? Okay, so let's to give a counter example. I mean, it's we can easily see this thing, right? F take a to be set -1 and b to be a set 1. What is a intersection b? Intersection b is empty. But then what is f of a intersection f of b? Okay, let's put, I don't want to get into trouble by mapping empty sets. Okay, here a intersection b is 2, and let's keep f is equal to x square. And what is f of a? And f of a intersection b under this mapping is 4. But this thing is what? Is 1 and 4. Fine. This thing is 1 and 4. This thing is 4. So in general, we have this. This is true. This is a subset of this thing. But you should think about what would be the answer to this thing. Do we have this? Do we have this? Yes, that is true. And this equality without inverses holds for union. Right? F of a union b is f of a union f of b. Okay, so let's go to second question. Yeah, so a number a is said to be algebraic if there exists a non-zero polynomial uh, such that f of a is 0. And here the polynomial coefficients are formed from what? Are formed from the rationals, right? The set of all the algebraic numbers are countable is the question. Yeah, I mean, you want to argue why it is countable?
You could take the set of all tuples and order them.
It's not exactly fundamental theorem of algebra. We do use it, but we use one more thing. Um, we are using one more thing in saying that countable. So here's a question. This is the question. So f of x is this thing is c naught plus c1x plus c2x square and so on cn x per n. Thing is this c naught to cn, c naught to cn belongs to rationals. Each of the c belongs to rational. Set of all rational doubles are countable. Cool. Yeah, this is what I was looking at. Yeah. Okay, so let me explain for everyone. So the number a is said to be algebraic if this is f of a is 0. Okay, and now let's fix this c naught to cn and from rationals. Okay, and then how many at max how many solutions we'll have to a, right? N solutions. Right, let's pick for every solution. We enumerate all the possible rationals from C0 to Cn. Right, so this is countable. For all the n solutions, if at all they are there, it's the union of all these countable sets, which is again countable. Is the argument fine? So this is for one n, one not, let's say one solution k. This is union of all the possible k's. K goes from 1 to n. I mean, it's strictly less than or equal to n. I mean, we'll need not have all n solutions possible for the polynomial. Fine, right? The key thing is this belongs to rationals, and each tuple of a rational is again rational. Again, it's coming from countable union of countable sets are countable. Okay. It's clear, right? You want me to spend some more time on that, or we can go for another next question. Okay, so if there are no questions, we will move on. We'll move on to the another one. What is the other one? Yeah. So yes, this is an interesting question. Let's. There are two sequences xn and yn converging to say xy. and you define two other sequences, mn, and which is max of x and yn, and again min of x and yn. Okay, so the question is, what happens to this max sequence and min sequence? Will they converge? It is option C. Yeah, both mn and mn exist, and say if x is less than y, xn and yn converge, and if x is less than y, do you want to tell what is the limit of them, in limit where they might end up? So here's a question. So if xn tends to x and yn tends to y, and I'm saying x is less than y, what are the limiting values of mn and small mn? Is the question clear now? It is less than mn, but what is the exact value? If it exists, it should have some value, right? X and y, cool. Yeah, that's what I wanted. Can we prove it?
In
Okay, so I'll outline the proof. Okay, so let's say this is a sequence which is converging around x, and let's say there's another sequence that converge around y. That means, I mean, sequence can come from any ways, right? They have to converge to x ultimately if it is converging. So let's say y minus x is delta, this difference. Now I'll put a delta by 2, or very small radius around x, and a very small radius around y. And you can pick anything less than delta, it will not intersect. These intervals will not intersect. Okay. Now let's remember the definition of the sequences, right? What is the sequence of what is the definition of sequence? Now xn converges to x if I'm saying, if I'm less than this small epsilon, which can be any delta by 100, delta by 10, whatever, right? Delta by 100. And similarly, yn minus y is less than epsilon, which can be delta by 100, whatever, very small delta. Okay, because I said this xn converges to x, yn converges to y, there exists an n corresponding to this delta by 100, right? I'm calling it as nx for sequence x. I'm calling this for ny for sequence y. Okay. Now consider this thing, max of this thing, right? We are considering xn gamma yn, which is cap mn. Okay. Now in the limit, if my n is greater than max of these two, right? my xn's will fall here, should fall here because of the definition of the convergence of sequence. All my yns should fall here, again by the definition of convergence in sequence, right? Now from this point onwards, it will be yn only when you pick n like this, right? And it will converge to y. Am I clear? Yeah, that is also cool. Whatever is being suggested, right? A plus b and a minus b by 2. Yeah. But again, then you have to argue that mod x will converge. Okay. Cool. Then let's go to another question. So, by the way, all this PDF will be uploaded, and so here's this sequence xn and yn. I mean, this is very easy. Xn is less than or equal to yn. Xn and limit yn both exist, right? So it's, I mean, it's easy to see that this is true always, because this is true for every n. The limit cannot beat the other sequence. Yes, that's true. And yeah, I'm not spending time on solving this. Yeah, so this is what I was saying. Now this is the sequence xn, and now given that xn is converging to a limit L, mod xn converge to mod L if this happens, and the converse can happen. Means if I give you mod xn converging to mod L, can you say that xn converges to L? Option B, option A, option B, both. Okay, so P is true, but the converse is false. So if you want to say any statement is false, you have to give a counter example. Uh, can you give a counter example for a converse? Option A is not correct. Converse is false. All right. Okay, I think constant sequence minus one is already converging, right? How it's a counter example? It's an alternating sequence. That's the right example. Yes, that's what alternating thing. Okay, so now we want to prove this thing. Okay, so xn, we are given that xn converges to this point L, and yn also converges to, not yn, I think we were talking about mod x, right? So prove that this happens. How do we proceed? How do we proceed with this? That's true. Yeah. So we have to use reverse triangle inequality here. So what does this say is this thing mod xn minus of mod L, this thing is less than mod of xn minus L. I mean, you can put a mod here actually. Less than or equal to. Okay. So now, I mean, you can see where we are going now. So for any n greater than say n naught for a given epsilon, right? I'm talking about this sequence now. Okay. So now what can we say is because this is converging to L, we have this. So we have this thing for this n, and hence we have this thing, which we are intending to prove actually, right? Clear? Okay. Yeah, so I think this is the three more problems are there, I think. Yeah. So now we have a sequence xn. Now what is being said is this um, if the odd sequence and even sequence converges to same limit L, can we say that the original sequence also converges to the same limit? And if the original sequence also converges to the same limit, can we say that odd and even sequences converge to same limit? Option B. Okay. So you want to argue why do we say that? Like x2n converges to L, x2n plus 1 converges to L. Now say that this implies that xn converges to L. Why do you say this thing? Can we prove it? Okay. I mean that's a logical argument. We will make it in in this notation. Okay. Now call this as sequence x prime n, and let call this sequence to be x double prime n. These are subsequences. Let's keep. Now we are saying x prime n converges to L. That means, as per the definition, we have this after psi n prime epsilon. Okay, now the same thing, x double n prime converges to L greater less than epsilon when you pick n greater than this thing. Okay. Now we want to test this thing, right? Xn minus L, where this sequence is there, right? No, let's pick n to be max of this, both this thing. N double prime epsilon, right? Now when we pick n max of this thing, right, and xn minus L should fall either in this category or this category. Okay, and hence once it falls into this category, you already have this thing, because it's already have this less than epsilon, this is less than epsilon. Now for the n given by this is this one, max of n1 epsilon and n double prime epsilon. Okay. Cool. Yeah, that's what for the converse, the other way around. If the sequence converges to a limit L, all of its subsequence has to converge to the same limit. Otherwise, sequence doesn't converge. Okay. It's clear, right? The argument. Yeah. So here's an interesting question. Now, if Xn is a Cauchy sequence such that the subsequence given by the even parts of the original sequence is convergent, then can we say that Xn itself is convergent? Oh, which one I should explain? The this part, right? The converse you want me to explain, or the true the So the converse is this, right? If a sequence converges, all its subsequence has to converge, x2 and x2 n plus 1, or any subsequence you can come up with. Or the other way around, is it? Okay. So I defined x2n to be x prime n. I defined x2n plus 1 to be x double prime n, right? And because it is given that x prime n, which is x2n, converges to L, then by definition of the convergence, we have this, right? For any n greater than n1 epsilon, have this, right? It's the same thing for x n double prime, right? Now what we have to argue is this original sequence have to be less than epsilon. Now if I pick n greater than max of n1 epsilon, n2 epsilon, right? So for this thing, right, xn minus L, this xn minus L will fall into this or this. Once it falls into this and this, we already have it is less than epsilon. So that's the argument. Clear? Even and odd are unbounded. No, right? They're bounded. See, the point is the convergent sequences are bounded, right? So this is a bounded sequence xn, and this is also a bounded sequence x2 n plus 1. Is it clear? So maximum is taken across this n's for which this will hold. It's clear. I mean, I can talk on this if it is not clear. So let's take an example. Say for this sequence, okay. So we are not taking maximum of odd and even numbers. So this is, say, this can be, say, 100, and say this can be some 50, or say 250. This an epsilon. We take to be 250. We pick any n much greater than 250, right? Then it has to satisfy this. Okay. Yeah, next question is an interesting one. So you have a sequence xn, and we are saying that this is a Cauchy sequence. Cauchy, right? And we have some subsequence x and k. Okay, let's prove this in generic terms, right? X and k can be odd, even, anything, and this subsequence also converges. Say to some limit L, it converges to some limit L. The question is the original sequence will also converge? Is the question clear? Okay, question is this: Xn is a Cauchy sequence. That means it satisfies Cauchy criteria for convergence, and x sub xnk is a subsequence of xn, and I'm saying this subsequence is converging to some limit L. Now the question is, what can we comment on the convergence of the original Cauchy sequence? So Cauchy sequences need not converge, right? That's what we started with. I mean, in beginning. Yes, it converges. That's true, but where? And how do we prove this? So how do we prove this? Any ideas? Right. So we want to talk about this point. Claim is it will converge to L. Now we want to talk about this point. Okay. So now we'll use the convergence of this thing, say x and k minus L will be less than some epsilon when you pick k greater than, say, n epsilon here. Okay. And now, because it is Cauchy, let's use that argument later, the Cauchy argument. I'll add and subtract the original, this thing, the given, the converging subsequence here, plus x and k. Okay, so now this is less than or equal to, by triangle inequality, okay. Now if I pick, because it is Cauchy sequence, right, I can pick any n any say some n, which is, so basically let's make this less than epsilon. Okay, so there exists some n naught, let's say, as long as n and nk is greater than n naught, right? This will hold. This will hold. I mean, this will go below epsilon. The thing is, now we need to pick k such that it satisfies this thing and this thing. Okay, so we can take the max of k to be max uh, of our this thing n naught and n epsilon, right? This will lead to say epsilon plus epsilon, this is equal to 2 epsilon, right? So original this thing is less than or equal to 2 epsilon. That's it. Is it clear? Yeah. So that's the general statement. Okay, if you are given a Cauchy sequence, and if we can find any subsequence to which is convergent, the sequence has to converge to the same limit. So I mean, we have done somewhat general thing here. Here it's a special case of the subsequence, which is nothing but the even sequences. Okay. Okay, so this is a proof of that generic thing. And let's try to solve the final problem today's sessions. Yeah, is the harmonic series, what do we say this? Forgot the name of this thing. Okay, is this series Sn, k goes from 1 to n, 1 over n, does this series converge? Yeah, it's harmonic only, right? Thanks, I was just confused. Harmonic diverges, yeah, any proof? How do we prove this? It's not complicated. Okay, let's see. Let's break this thing. 1 plus say 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8 and so on. Okay, so the idea of the proof is to find a sequence which is lower than this, I mean whose sum is lower than this, and show that it diverges. Okay, so you see this thing, this sequence, do you agree that uh, I mean plus so on, so let's keep, I would like to keep this 1 by 2 to be same thing. Now this sequence will be greater than or it's strictly greater, it's not even greater than or equal to, right? If I replace 1 by 3 by 1 by 4, do you think it will reduce the value or increase the value? 1 by 3 is bigger than 1 by 4, right? So this is strictly more than this. right? So now the trick is this. 1 by 8 here is there, right? Replace 1 by 7 with 1 by 8, 1 by 6 with 1 by 8, and you will further increase the value of this, the above one, or further relatively reduce this thing, right? 1 by 8 plus 1 by 8 plus 1 by 8, so on, 1 by 8. Okay. So let's give a name. How many terms are there here? 1, 2, 3, 4, 5, 6, 7, 8. So let's call this thing to be S2 per K. Okay. So when K is equal to 3, this is the thing, right? When K is equal to 4, I'll have 16 terms. Now each of this will, in the summation will be 16, and you will, how many terms will have here? 8 terms will have here, right? 1 by 9 to 1 by 16 we are replacing. So we'll have 8 terms. So this is nothing but 1 plus, you have this 1 by 2, right? Here also you have 1 by 2. Here also you have 1 by 2. For 3 it will be this. For 4 it will be, you will have 1 over this thing. So this is nothing but 1 plus K by 2. K by 2. Okay. And in the limit K tends to infinity, right? S2 power K is diverging to infinity. So a lower sequence than this is converging to infinity. So the original sequence has to converge to infinity. Okay. In general, if you see results, right, anything 1 over square root of n will also converge to infinity. 1 over 1 n per 1 by 3 also converge to infinity, and so on. Okay. So that's the proof of the divergence of harmonic series. Okay. I hope things were clear. Okay, so let's meet next week, same time, 3 to 5. I mean, we need, if possible, we can go for 5, but typically we don't need. I mean, if you have more questions and if discussion is engaging, we can have more time, but typically that doesn't happen. Okay. Okay then.